Continuing on with our 10.6 lesson, we're looking at real-life examples of exponential growth and decay. So in this example, we say that a paleontologist examining the bones of a woolly mammoth estimates that they contain only 3% as much carbon-14 as they would have contained when the animal was alive. So how long ago did the mammoth die? Well, remember, from our note, we said that the K of carbon-14 is 0.00012. And we know that we're using a exponential decay form because over time we're losing the carbon-14, so it would be y equals a e to the negative kt. Now again, we don't necessarily know how much we started with, but we know that only 3% is left. So we would say then that 0.03 times however much we started with equals, so I'm going to go back to black, equals however much we started with times e times negative k, or negative 0.00012, times t, our years. That's what we're trying to find. Well, things that we can get rid of, a and a. We divide it out. It doesn't matter how much we started with, we just know that only 3% of it is left. So now we have 0.03 equals e to the negative 0.00012t. So again, we just use our properties of logarithms and say ln 0.03 equals ln e to the negative 0.00012t. These ones will cancel out. So we have ln 0.03 equals negative 0.00012t. So to find t, get t alone, we just have to divide both sides by that decimal value. So we would say ln 0.03 divided by negative 0.00012 equals t. Plugging that into our calculator then, this will give us that t equals 29,221.31 years. So that woolly mammoth died a long time ago. Cool beans. So let's look at one where we're actually doing exponential growth. The population of a city of 1 million is increasing at a rate of 3% per year. If the population continues to grow at this rate, how many years will the population have doubled? So when we're talking about doubled, and we started at 1 million, again, we know that it's exponential growth, so we would do y equals a 1 plus r to the t, because it's growing every so often, and it grows by a certain amount. It grows by 3%, so that's why we have to use the 1 plus r. We know that our initial value a is 1 million. We know that we doubled, so our y, where we end up at, is 2 million, because we doubled 1 million. We know that our r value is 3%, and t then is what we're looking for. So let's just plug in everything we know. And I'm just going to keep it as writing out million. So we'll say 2 million equals 1 million, so I don't have to write all those zeros, times 1 plus our r value of 0.03 to the power of t. Now from here, we can divide both sides by 1 million to start getting rid of some stuff. Divide by 1 million, divide by 1 million. Essentially this goes away and we're just left with 2 over here, because 2 million divided by 1 million just gives us 2. So now we know that 2 equals 1 plus 0.03 to the t power. So we could rewrite that as 2 equals 1 plus 0.03 is 1.03 to the t power. Once we're here, we go back to using properties of logarithms. And we would do ln of both sides. Ln of 2 equals ln 1.03 to the power of t. using properties again, t ln 1.03, and dividing both sides by that natural log, we would get, I'm going to give us a little more room to get there, ln2 over ln 1.03 equals t. Solving that out on our calculator then, t equals 23.45 years. So after about 24 years, that city is going to go from 1 million people to 2 million people. Pretty neat.